So this is the Tanshu Kumar, and I have Mahesh Kumar with me, and we will be presenting our Unleash LLM prototype, which we built for this hackathon. So essentially, what we made is a study bot, which is an AI-powered learning companion. So the main thing here is main functionality of this bot is first we upload the documents and it generates questions from them, as well as it also summarizes them, and it also, for example, if you have a query you can ask it, and using RAG it answers the query. And there is also a fallback mechanism which uses cosine similarity to measure the flow of answers between like LLM which is using RAG and LLM which is answering using the generic response. So it measures the similarity, and if the flows are similar, uh, it does not. If the flows are very dissimilar, it probably means that the LLM is giving wrong information, or the reliability metric is kind of low. So we have implemented this reliability metric also. So so essentially, it goes with document uploading. LLM is processing. For this particular prototype, we have used the Llama 3 instruct variant, and we are using BAI BGM3 embedding from Hugging Face. So the innovative aspect is we are using an open source LLM, which is Llama 3, using Llama index, and we have used constraint token generation to get proper JSON schema to display in the front end. So mitigating hallucination is also, we are trying to do using a reliability metric using cosine similarity. So here is the demonstration of the prototype. I think I have also opened it here. So this is a prototype. Like, it takes some time. So I have as of now recorded a video here in the PPT itself. So first of all, I run my UVCon server, then start the front end, and here I upload Principles of Quantum Computing PDF, which was our college second semester course. So now when we click the summarize button, it essentially summarizes the entire document. So here is the document which is summarized by the LLM. So essentially here this is happening is essentially we are chunkizing the text itself into multiple blocks, and then feeding the LLM one by one so that we don't exceed the token limit of the LLM. And so the summary it generates is quite accurate. So I think here, yeah, here is, we are chunkizing them and summarizing them, and this is the original, just uploaded it to it right now. And then there is quiz. So it this is Llama Index LLM pydantic program where it completes using JSON schema. So for this we have two classes here, which is MCQ with base model, and there is this MCQ set, which is the list of questions. So the question has three things. One is the question itself, then it has options, which is a list, and then we have answers, which is a string. So we are using LLM text completion program of Llama Index, and then passing the chunk wise part of the PDF to it to then formulate questions from them. And this is the prompt we have given the LLM, and the front end part and how it looks out from the outside. And when we click on the, so we get, if it was wrong, we get a red color, and if it's right, we get a green color. The correct answer is B, by running parallel data channels through. So, and this is the query mode. Here we write. So now from the document, it see, it will, for this, because this qubit is related to the document, it will give something of this. A qubit is, can be thought of a coin spinning in air. It gives, and if I ask relevant to the document, which is what is uh, it will say something like this, because we have implemented a reliability metric using cosine similarity. So it will say something like reliability is low, please refer to the other sources, like wiki. There is no mention of Google or any related topics. And the way we have essentially implemented the reliability metric is we are completing. See, this is the similarity function which measures similarity between two um, texts, and we are measuring the flow between a text from the LLM and with track and one without track. And for the future scope is like personalized learning is one of the future scopes of this particular project, and it also supports a wide variety of content. That's why it's diverse, and it has because we can implement different models as models improve. This project will itself improve. And one of them is like mobile integration. If we can host it on virtual machines, we can essentially um, access this particular study bot using mobile phones. And as for the carbon footprint calculation, because this is running on my laptop, and my power brick is of 250 watts, and I believe a session is about 10 minutes. Grid emission factor, which is 0.5 kilogram CO2 per kilowatt hour, is essentially the standard metric, like the global considered metric. So we are converting 10-minute session is 0.167 hour, and total power consumption is 0.417 kilowatt per session. And by multiplying it to the grid emission factor, we get 0.021 kilogram. Therefore, about 10 minutes of computing session on this GPU will result approximately 21 grams of carbon dioxide emission equivalent.